Welcome to Study Loop.
Hello friends, as shown in the diagram, it consists of 4 thin 16-inch diameter semicircular aluminum plates welded to a light 40-inch long shaft AB. Weight of assembly is given 12 pound. Initially it is at rest. When a couple M knot is applied to it, causing the assembly to complete one full revolution in 2 seconds. Calculate the couple M knot in the part A, and in part B dynamic reactions at A and B at T is equal to 0. Let us see here. We start solving now. We can observe fixed axis rotation. With constant angular acceleration. Here alpha is equal to alpha I and omega is omega I. Theta is equal to theta naught plus omega naught T. This is 0, this is 0. Alpha we are calculating, T is given 2 seconds. So alpha you will get, just a moment, half alpha, and this is one revolution, so alpha is equal to 2 pi upon 2, that is pi radian per second square, or you may write 3.1416 radian per second square. Now angular momentum will be Ix omega I cap Ixy omega j cap minus Ixz omega k cap. Angular velocity of a reference frame Cx by z omega 2b omega I cap. So rate of change of angular momentum about C. Rate of change of momentum about C, you may write C Cx by z plus omega cross Sc. It will be Ix alpha Ixy alpha j minus Ixz alpha k plus omega I cross Ix omega I minus Ixy omega z minus Ixz omega k. So here it is a cross product. So on simplifying, it could be written as Ix alpha I minus Ixy alpha j minus Ixz alpha k cap, taking the cross product, so it will be 0, or you may write it would be Ixz omega square j minus Ixy omega square k. Say this is equation 2. Now we have to find moments and product of inertia. Moments and product of inertia. Let mass per unit area is m upon a. Assembly can be divided into 4 parts, and for each part we are finding the value. Here we will construct the table. X-axis, Y-axis, Z-axis, assembly 1, assembly 2, assembly 3, and assembly 4. Part area Ix, Ixy, Ixz. First, half pi r square 1 by 8 pi r4 minus 2 by 3 r की power 4 0. Second, half pi r square 1 by 8 pi r की power 4 0 minus 2 by 3 r की power 4. Third, half pi r square 1 by 8th of pi r की power 4 minus 2 by 3 r की power 4 0. Fourth, 2 pi r square, sorry, half pi r square 1 by 8th pi r की power 4 minus 2 by 3 r की power 4 that I have written wrong. It will be 0. So if we find the summation, it will be 2 pi r square half pi r की power 4 minus 4 by 3 pi r, 4 by 3 r की power 4. Here r is given 8 inch, that is 0.6667 foot. Mass is 12 by 32.2 slugs, that is 0.37267 slugs. I mass is equal to rho into I area. Now calculate the value. Already we have prepared the table. Only we have to substitute the value. Density you will find rho is equal to m upon 2 pi r square. Mass we have calculated 0.37267 to pi 3.14. Radius is 0.667. So density we will get 0.13345 slug per feet square. Ix will be rho, that is 0.13345 into half pi r की power 4. R is 0.667 की power 4. So on solving it, it will be 0.041407 slug feet square. Ixy you may calculate 0.13345 minus 4 by 3 pi, minus 4 by 3 r की power का 0.667. So it will be minus of 0.03547 slug feet square. Ixz you can find 0.13345 into minus 4 by 3 r की power 4. So on solving it, it would be since mass per unit lies on the axis of rotation, so acceleration is 0. Since the mass center lies on axis of rotation, So A is equal to 0. So summation of F is dynamic reaction at A plus dynamic reaction at B. That must be 0. So dynamic reaction A is equal and opposite to B. So this is the one of the important relation. Now moment about C you can find MOI cap plus minus BI cap cross A plus BI cross B 2B is equal to M naught I 2BI cross B by J cap plus BZ K cap. So we can write MOI plus 2B by I cross J K cap minus 2B BZ J cap. Here remember it, 2B is 40 inch, so which is 3.333 feet. Now say this equation is third equation. Now summation of MC is equal to HC. Substitute the value MOI minus 2B VZ I J cap plus 2B B by K cap is equal to HC, or HC we know it is I alpha IX alpha I cap minus IX by alpha J cap minus IXZ alpha K cap plus IXZ omega square J cap minus Ix by omega square K cap. Now finding the components along I cap, J cap, K cap, so you will get the answer. If we take the component of I cap, you will get MO to be equal to Ix into alpha. Ix already be calculated, alpha we have calculated, substitute the given values. So you will get 0.041407 into alpha, that is 3.1416. So you will get the value to be 0.1301 pound fit. If you write in vector expression, it is along x-axis, so we can write 0.1301 pound fit I cap. So this is the answer of part A. Now we can find the answer of B part by equating the coefficient of x, y and g, that is j cap and k cap. Evaluate using the components of above equation along j cap. You will get minus 2b bz is equal to minus ixy alpha plus ixz omega square. So from here vz you will get, since omega is 0, so this term becomes 0. So you may write ixy alpha upon 2b. Now substitute the value. Ixy having the negative value 0.035147. Alpha is pi, that is 3.1416. This term already becomes 0 because omega is 0. Minus 2b is 2. Minus 2b is 3.333. So you will get minus of 0.0331 pound. Similarly, for K cap, you may write 2B by is equal to IXZ alpha minus IXZ omega square. Again, omega is 0. So from here, we can find the Y component of dynamic reaction at B, and it would be IXZ alpha upon 2B. Remember it, omega is 0. Now substitute the value. You will get minus of 0.035147. Alpha is pi 3.1416 upon 2b, that is 3.333. So it is also 0.0331 pound. So we can write dynamic reaction at B point is 0.0331 J cap minus 0.0331 K cap pound. Similarly, since as we know dynamic reaction A at A is negative of that of B, so A could be written as minus 0.0331 J cap plus 0.0331 K cap. This is the answer for this problem. Thanks for watching it.